pretty fundamental thing about distributed consensus, and the fact is that it's essentially always a voting mechanism. Nodes in a distributed network perceive things at a different time. And if you would have the perfect voting mechanism and you could ask every node and learn about the opinion of every node in the network, and you would ask them, like, who has seen A before C? Then it would be 2/3 of the node that would say, I have seen message A before message C. Even if you have the perfect voting mechanism, you cannot establish a total order in a distributed system at all times. For an account-based ledger, you always need to have a total order of events, at least within the set of modifications for a single account. Account-based model kind of needs this total order. So then ask yourself, is there another ledger state model that doesn't have this limitation? And there is one, which is called the UTXO model. What transactions do is they reference the output that they want to spend. Usually you call this an input. And then they produce new outputs. So the only thing that needs to be okay for the transaction to be valid is that the signature matches the address, and that the amount of funds that you create and the amount of funds that you consume are essentially the same. The ledger state, so the actual balances that you see when you ask the DLT for how much money is on which address, is essentially always the end, or like the tip of this DAG. If I change the order and say transaction 2 gets processed after transaction 4, the ledger state stays exactly the same.
There are two major ledger maintenance models in blockchain technology. One is account-based, as in Ethereum, and the other one is UTXO, which stands for unspent transaction output. If you want to design state channels, of course, we have to ask ourselves the question whether the way we maintain the ledger impacts the design of our state channels. And not so amazingly, the answer is yes. Now assume you want to take a contract off-chain. That means you have to find out what the state of this contract really is. And how do you determine the state of a contract in an account-based model? Don't try to, because it's really hard to tell. It's because the contract state is part of this really entangled global monolithic state. In the UTXO model, it's different because each output carries its own validation code. If I want to take a contract state off-chain, I just have to collect all the UTXOs that belong to this smart contract instance.
So Bitcoin and also Cardano make use of what's called UTXO, unspent transaction outputs, whereas Ethereum uses what's called an account-based way of doing things. But there are actually some advantages to using unspent transaction outputs. Account-based, you might think, oh, that's a lot simpler. But the thing about accounts is you don't know in what order these transactions will appear. So the reason that UTXOs work so well is transaction 3 here specifically refers to transaction 1 and transaction 2. With UTXO, that's the way it works. With accounts, it's just whatever order things happen in, and you don't know what's going to happen. Because under UTXO, you know exactly how much gas you're going to use. Under accounts, you don't know. Depending on the order things work, your transaction might be invalid, or it might be valid but use 10 or 20 or 30 gas. You don't know.